What's going on YouTube? It's me, Dominic, and today I wanted to go over the exercise in the C programming textbook by the infamous K&R. So basically this textbook is supposed to be a get-rich-quick scheme. No, I'm just kidding, it's not. It's quite proving the opposite, but nonetheless, we're on exercise 1-14, which is a part of chapter 1. I'm in the section talking about arrays, and this one is challenging us to write a program to print a histogram of the frequencies of different characters in its input. So simply put, you're going to pass in a text file or some sort of text input into your program, and it's supposed to determine how often a character appears in that text, right? So let's go ahead and hop over to our terminal here and head into our application itself. Now I already have the code written out, but I'm going to go ahead and walk through kind of the troubles that I ran into and just walking through the logic, within the code itself. We start off by including the standard input-output library, so that's pretty self-explanatory. We're going to be interacting with that there. I have a little message that basically tells us what this program is going to be doing, which is kind of what I explained to you guys already. And we're going to go ahead and define the main function and declare two variables, C and I, both integers. And we're going to be using these as mappers for ASCII values and for iteration purposes. And we have an integer array called frequency or freq. And basically, this was where I ran into my first issue because I came from exercise 1-13, which basically was the same thing, but it was a state machine. And all that means is basically it would determine within the application itself if you were in a word or not, and you were trying to determine how often a word would appear, or how many different words are within the input that you pass the program. Now, it would track the state in or out depending on if it was in or out of a word, and you would basically find that out by checking to see if the character you were iterating over was a space, was a tab, or something that wasn't a traditional ASCII value. And it would say, okay, this isn't a letter, so I must not be in a word, or I must be in a word. And then from there, you could increment up a counter that would determine, hey, you have this many words within your text file. So all that to say, I struggle to determine the size that the array should start out at. And I think this harps on a good point that in our day-to-day lives, especially with the emergence of AI technologies, I think that oftentimes that I want to reach out and immediately go to Claude and be like, hey, why is this not working? Explain this to me, without really taking the time to think about the problem at hand and the problem that I'm trying to solve. And so with all that to say, essentially, I asked myself, how many characters can an output possibly have, right? And we know that ASCII values are the ones that map properly to, digits within C. So within this, I don't know if it's UTF-8, or I'm not sure exactly what standard this mapping comes from. I don't know if it's ASCII itself, but there are actually 128 possible ASCII values that could possibly exist within a text file. So that pretty much gave me my short and sweet of it. But at first I was putting just random integers. I was like, how can I possibly know how many different characters are going to be within a text file? Like, what if there's Mandarin? What if there's Russian inside of my, program? How is it going to know that? Well, ASCII only defines the 128, apparently. So shout out Stack Overflow, shout out DuckDuckGo. We don't use Google around here, okay? We're privacy geeks, okay? But anyways, There's 128 possible ASCII values that we can have in our array, so we're going to go ahead and move on to this for loop here, which essentially is saying for the duration or the size of the array, we're going to iterate through each one of the indexes or indices, and we're going to set each value to 0. So we're basically baselining our histogram. We're saying that we haven't seen any characters yet, so everything is going to be 0, right? So each one of those indexes is going to return a 0. We're going to print a banner that basically tells you what kind of program you're running, and then we're going to go into our while loop, which is basically going to say while C, which is our integer iterator, which is going to map to an actual character. You're going to go ahead and get the character of the current iteration while what you're reading is not at the end of file, which, as we know from the C textbook, it tells us that EOF actually has a value of -1. So every other value is going to return, I believe it's 0, and once it hits the end of file or -1, it knows to stop looping through. So this is going to basically take in our input, and it's going to read it fully until it hits that -1 point, and for each character you're going to find the corresponding ASCII value that we've already mapped, because only 128 exist, and you're going to find that value, which C is going to correspond to a ASCII value, if that makes sense. So the character of A is going to go to, I believe, 64, 65, and it's going to say, okay, I saw an A, let's increment by 1. So there we go. Now we have values mapped for each one of the characters we have in a text input file we've passed into our application. Now, the next thing is going to be this other nested for loop, and this is the part that I was having troubles with, and this is just printing out the values in a way that is meaningful to us. And since the data that we're trying to present to you is a histogram, all that means is that we're going to have basically a bar down on the left side and stars or bars, if that makes sense, kind of like a bar graph, but it's going to be horizontal, showing you how often a character is found within a set of text, right? So let's think about that on a logical level. We're going to go ahead and have to iterate through our existing array that we've mapped all these new values to, right? So now there's actual character mappings and values for how often those were found in there. So, how many A's, how many B's are in there, and basically we're going to say if there is a value that is greater than 0, so if the character is actually found within the text you pass into the application, let's go ahead and print a column for that, or what is this? The vertical bar, the vertical side, like a graph is like this, right? So go ahead and print this if you find the actual character within that array, right? So then next thing you want to do is you're going to make another loop to go through each one of those that have been printed, right? So just drop the remote on the ground. But for each one of those values that we actually detected within that text file or the text we've passed into the application, let's loop through each one of those characters, and for each number that's within there, the actual value at the I index, we're going to print as many characters or as many asterisks in this scenario as there are numbers. So if there's 49 A's, there's going to be 49 asterisks. And we can change that to periods, for example. Let's go ahead and save that just to demonstrate this purpose. And then after each one of those columns that we've printed, or one of the lines for each value, the ASCII value is actually found, we're going to print a new line so it's actually properly formatted. And that completes the entire application. So it's pretty cool, pretty neat, right? This is a pretty neat application that actually has practical use. You can determine just random statistics about your files on your system. So for those that don't know, I love Linux, and so I'm using the window manager called Hyperland, and it comes with a configuration file, as many Linux operating system software does, and they recently just switched to Lua, and if you guys want to talk about it, let's talk about it down in the description down below. I don't know why we did that. Anyways, let's go ahead and pass in the Lua configuration file for Hyperland into this application. But first we need to go ahead and compile it. So let's go ahead and GCC this, and we're going to tell it to output our binary to something called program. So after that, there looks to be no errors. So if I go ahead and read the contents of my current directory, we can see that program is right there, nice and neat. So let's go ahead and execute the program by running /program, and we're going to go ahead and pass in our configuration file. And as you can see here, on the left side of the screen, due to the formatting that we have here, we have the character itself, a space, and then we have a vertical bar to separate the periods in this example from the actual character that we have in the array. But as you can see, the first thing, this looks to be a tab. There's a ton of tabs, or a multitude of tabs. It looks like 2 tabs right there, and there's this many periods for that, so on and so forth. So for each character, you can see that for this, what do you even call this? Quotation mark? There's a ton of those. For the $sign, I don't even know the name of these signs. I don't know what's going on here, but sorry about those notifications as well. But we also have, the apostrophe, we have parentheses. All of these different symbols will show how often they appear within that text file that we've passed in. So I think that that's pretty neat, and I wanted to show you guys how I went about implementing my solution. And so if you found this anyhow useful, or if you thought this was pretty neat, let me know what you thought about it in the comments down below. Otherwise, guys, have a blessed day, a blessed Friday. I'll see you guys in the next video. If you want to follow along with me on this journey to learn C, make sure you hit that subscribe button. I will see you next time. Peace.